Good morning, friends. So today we will continue our study in relation, functions and binary operation part 4. Up to part 3 we have already seen. Today we will start from the part 4. Till now we have studied what is a relation, what are the different types of relation, what are the different types of functions. Today we will see more in function, and we will start in function today, composition of functions. Composition of functions. Hence we say graph, fog, etc. Let's see. Suppose we have two functions. Suppose there is a function a which is f, which is defined from a to b, and we have a function g which is defined from b to c. So let me represent here by the diagrams. This is a function f from a to b, and this is a function g from b to c. Then suppose we have some elements here, 1, 2, 3, 4. We have some elements here, a, b, c, d, and we have some elements here, P, Q, R, S. And the function from A to B is defined like 1 is connected to A, 2 is connected to B, 3 is connected to B, and 4 is connected to C. And a function from B to C, that is G, is defined as A to P, B to Q, C to Q, and D to R. Suppose this is a function. Then we say a function which is defined from A to C. A function from A to C. We can take one function from A to C. Then see what we say. We say this function is, suppose this is x, then it will go here under this f, that will become fx, and that fx will go here, and that will be g of fx. So if any element I am taking x, its image will be f of x, undergoing transformation into g, that will be g of fx. So this we say graph, that is g of fx. And this function is defined from A to C, and we will consider only the connected elements throughout. Means this will be defined from, graph function will be defined from A to B, or better I will write in the symbolic form C. 1 is connected to A, connected to P. So this will be defined from 1, and here I am writing its range, 1 to P, 2 is connected to B, B to Q, 2Q, 3 is connected to B, B to Q, so 3, 4 is connected to C, C is connected to Q, so 4Q. That's all. Here we will not consider this element D. Why? Because we don't have any pre-image for D in this A. So this will be our graph. The domain of graph will be 1, 2, 3, 4, and the range of graph will be PQ. Codomain will be all this, but we are considering here we will only the domain and the range. So range of graph will be PQ only. This and this is not connected at all, and this is connected to D only, not this D is not connected to here A. So we will discard this while considering the range of the function of the graph. That is how we define the graph. Similarly, if we first give G, then f function, then we will give the fog, that is f of x. This is how we define the composition of the functions. Let's see more. Now see some examples. Suppose we have a function fx equals to x squared and gx equals to cos x. The question is saying find fog n of state if fog equals to cough or not. Suppose this is the question. See, first let's see gof. What is gof? G of fx. Now g of, what is the value of fx here? X squared, g of x squared. Now g of x squared, replace here x by x squared, we will get cos x squared. So here gof we are getting cos x squared. Let's find out the fog. Fog is f of gx, that is f of, what is gx? Cos x. And here f of cos x, replace here x by cos x, we will get cos x whole square, and that is how we write cos square x. If we compare this gof and fog, obviously these two are not equal, because here x power 2 and here cos x to the power 2. So we can write in general fog not equals to cough. That is the thing. So in general fog not equals to cough. It may be equal, that is the different case, but in general it won't be equal. Let's see next question. Suppose the question is saying fx equals to 3x plus 4 by 5x minus 7 and gx equal to 7x plus 4 by 5x minus 3. Find fog and gof. Now see, and also we have to check either fog is equals to gof or not. Let's see. First see fog, that is f of gx, f of, what is gx? Gx is that much, so we can write 7x plus 4 by 5x minus 3. Now here replace x by this quantity. So if you replace, we will get 3 into this whole 7x plus 4 by 5x minus 3 plus 4 divided by 5 into 5x minus 7, 5 into this whole 7x plus 4 by 5x minus 3 and minus 7. Here I have replaced x by this factor, so we will get this one. Let's simplify it. So after simplifying, we will get 21x plus 12 plus 20x minus 12 divided by 35x plus 20 minus 35x plus 21. I have taken here the LCM and I have cross multiplied. In the denominator we are having 5x minus 3, so it will get cancelled. Now here plus 12 cancel and we will get 41x by here 35x cancel and we will get 41. So what we are getting? X only. Now let's find the GOF. Now GOF is equals to G of fx. Now see, G of, put the value of fx. Fx is this one, 3x plus 4 by 5x minus 7. Now we have to find G of this factor. So replace x by this whole. So what we will get? We will get 7 into this whole one, 3x plus 4 by 5x minus 7 plus 4 whole divided by 5x minus 3. 5 into this whole factor, 3x plus 4 by 5x minus 7, 5x minus 3. Let's simplify it. So this will get 21x plus 28 plus 20x minus 28 divided by 15x plus 20 minus 15x plus 21. Let's simplify it. 28 gets cancelled. We will get 41x by here 15x cancel, 41, that is equals to x. So what we are seeing here, fog x equals to GOF x. In the previous question we had seen this not equals to this. In this question we are saying this equals to this. So we can say either this may be equal or may not be equal, but in general this won't be equal. Okay, so that is the solution of this question. Let's see the next question. Suppose the question is fx is given as 3 minus x cube to the power 1 by 3. We have to find f of f. Means f of fx. Let's see. Here f of f means f of fx. So this is a composition of functions in itself. So f of fx, replace here x by fx. So what we will get, f of 3 minus x cube to the power 1 by 3. Now f of this whole quantity, so here replace x by this quantity. What we will get, 3 minus x, replace x by this, 3 minus x cube to the power 1 by 3, whole cube is there. So whole cube, 3 minus x cube whole to the power 1 by 3. Right? Now let's calculate it. So 3 minus, now this and this will get multiplied and we will get 3 minus x cube only whole to the power 1 by 3. Now this can be written, if we break it, this and this will get cancelled and we will get x to the power 1 by 3. Now this and this will get cancelled and we will get x only. So this is a composition of function in itself. Okay. Let's see the next question. Now we had seen this enough problem on it. Now we will see the inverse function. Inverse function. Okay, let's see what is it. Suppose there is a function f from a to b. If we define a function from b to a, then that function we call f inverse from b to a, and f will be from a to b. Suppose we have some elements here, 1, 2, 3, 4, a, b, c, d. A is connected to A, 2 is connected to B, C is connected to C, 4 is connected to D. Now, suppose this is the function f from A to B. The domain is 1, 2, 3, 4, range is A, B, C, D. So for f inverse, the domain of f becomes range of f inverse, range of f becomes domain of f inverse. Now for inverse to exist, the first condition is function should be 1, 1 onto. See why. If the function is not 1, 1 onto, what will happen? 1, 1. Suppose we are getting the function like that. If we define from the function from a to b, if we define, okay, this will become 1, 1. This function will be defined. If we are defining from b to a, the a will have 2 images, and that is not valid in case of a function. Okay, so the function should be 1, 1, and why it should be onto? Suppose we are having some element remaining here, then from a to b, no problem, but while coming from b to a, this function, this element will be unused. Hence the function should be 1, 1 onto for a inverse to be defined. That is the main condition for inverse to be exist. That is the thing. Now see how to find the inverse of a function. Find inverse of following. The first is fx is given 3x minus 2. Obviously this function is 1, 1 onto, because the graph will be 3x minus 2, the graph will be something like that, y equals to 3x minus 2. Okay, now see, this function is 1, 1 onto function. So how to find the inverse? What you do, you find the value of x in terms of y. So from here we have y equals to 3x minus 2. So x will be equals to y plus 2 by 3. Now consider this as f inverse y. So the inverse of this function will be x plus 2 by 3. That is the thing. Y replace to find the inverse of a function. To find the inverse of a function, find the value of x in terms of y, and that will become the inverse. Why we are doing that? Because each x will go to y, and y again will come to x. That is what we are doing in the inverse of a function. So this is the inverse of this function. Let's see the next question. We have to find the inverse of this. Y equals to e to the power x, where E is a constant that we know the value of E is approx 2.7. This is again 1 1 onto function. Why? Because the graph is like that. So this is 1 1 onto function. Now see how to find the inverse. From here, take log both sides. So we will get ln y equals to x into ln e. That will become x. So this we will get f inverse y. So the inverse of this function will be ln x. Okay, and the graph of ln x will be like that. Fine. So this is the inverse of this exponential function. Here we can see the exponential and this logarithmic function are inverse of each other. Okay, let's see the next question. Now see, in some of the functions, the function will not be 1 1 onto function, but by putting some constraint, we can convert that into 1 1 onto function. That we had seen in case of when we were studying 1 1 onto function. Let's see. Suppose the third question is, we have function y equals to x square. We have to find the inverse of it. Okay, let's see. The graph of y square we know is like that, y equals to x square. Obviously, this function is not 1 1 onto function, right? See what we will do, what technique we use here. If we see from 0 to infinity, okay, the function is 1 1 onto, right? We are saying case 1. If the function we are defining from 0 to infinity to 0 to infinity, what will happen? The function will become 1 1 onto function, right? In that case, we can write y equals to x square. Hence, we can write x equals to root y. That will become f inverse y. Hence, the value of inverse function will be root x. Okay, so we are applying here some constraint. Okay, that what constraint I am applying? The function I am defining from 0 to infinity to 0 to infinity. In this situation, the function, the graph C, I am taking from this branch only. So that will become 1 1 onto function. Hence, we can find the inverse of it. Okay, now see the case 2. If we see this part also, when we are going from 0 to minus infinity, this part of the function, okay, that is also 1 1 onto function only. So the second case also we can take, fx is a function defined from minus infinity to 0 to minus infinity to 0. That will again become 0 to infinity. The range is from 0 to infinity. The function again is 1 1 onto function in this. The domain is from 0 to minus infinity, and the range you can see 0 to infinity. Again, this is 1 1 onto function. So again we can write y equals to x square, and x we can write minus root y. Because here x value will be always negative, that's why I have taken the negative sign. So that is our f inverse y. So in this case, the f inverse x will be minus root x under this constraint. So the inverse of this function we can define either this or this. By putting some constraint on the function, we can define the inverse of a function. That is very important. That is how we find the inverse of any function in the constraint, domain and range. Okay, that is the thing. Okay, okay, now I am stopping my class. The next class we will continue from here. Thank you.